Question 6. The random variable z is distributed normally with a mean 0 and a standard deviation of 1 and a variance of 1, because 1 squared is 1. The event A is such that z is greater than 1.1, and B is the event that z is greater than negative 1.9, and C is the event that z is between negative 1.5 and 1.5. So the question asks to first find the probability of A happening. So we've been told in the question that z, they've chosen z on purpose because it's the standard normal, it's just an arrowhead, z, is distributed normally with mean 0 and standard deviation of 1. So we basically lose all our data by the time we are 3 standard deviations from the mean. 3 lots of 1 is 3, and 3 lots of 1 heading down is negative 3. So this is our standard normal graph. And we're trying to find the probability of A, and A is the event that z takes a value greater than 1.1. So we're looking for this. What proportion is shaded out of this whole graph section? So in order to work that out, we would need to go to our z tables, and you will need to look up the value of 1.1 in the table for z. And when you do, you will get a probability of 0.8643, and that's because it's reading the probability in this direction. So this section can be labelled 8643. Now, to find the probability that we want, we're going to need to do 1 take away that value. And so I can add on from here until I get to 1. So if I add 7 to that, I'll get to 10. Then I need to get this up to 9, that up to 9, and that up to 9. So I get this, 0.1357. Okay, part B. Find the probability of B. Now B is again to do with z, the standard normal, which is centered around 0 and pretty much disappears at 3 and minus 3. I mean, we are asymptoting, but there's pretty much nothing there. And we're told that z needs to be greater than negative 1.9, so that's about there. So we're looking for this. Very large probability. Now, we can't look up negative 1.9 in the tables, so instead we look up positive 1.9, which would be symmetrically over here. And when we look up 1.9, it gives us 0.9731. So it's looking this way, like all of this up to this line is 0.9713. Well, that part, if we reflect it in the axes here, is equal to the part I've shaded. So actually, by looking up positive 1.9, I've got the right shaded section of 0.9713. And that's the answer for part. It's not part B actually, it's part II. And these are each only worth 1 mark each, so you just have to get the correct answer here. Part III says probability of C. Now, we are again looking at the standard normal distribution, but this time we're going from negative 1.5 to 1.5, and we're interested in what proportion of the area of underneath this graph is shaded in. So in order to work that out, there are different ways to do it, but I'm going to look up 1.5 in the table. You'll definitely need to do that. And when I do, I get 0.9332. And that's because it's reading this from here all the way up to there. That can't be right, that's way too high. Let me just have another look. No, it does say 0.9332. Well, I guess I haven't drawn the graph that accurately, because really it would dip down quite a lot like that on the way to 3. So there we go. So up to this point is 0.9332. So the way that I'm going to find this area is, so I'm going to take that all the way up to this point, but then I'm going to subtract this part, 0.5, from that, so that I get just this piece in here. So this piece is 0.9332, which is all the way up to there. Take away 0.5, so take away that, will leave me with just this section, which must be 0.4332. But I don't want just this section. I need also this part as well, which is exactly the same size because of the symmetry, and so my final answer is 0.4332 doubled, which gives me 0.8664. That's worth 2 marks. Now for the last part, it says find the probability of A union C. Now, there are a couple of ways to do this, but one quite sensible way is just to think about what the union of A and C means. It means, what is, in words, what is the probability of A or C or both happening? Well, let's just think about that, because what do we know about A? A is the event that Z is greater than 1.1. So if I drew a number line for Z, let's just put 0 there, for example, here could be 1.1. So A is illustrated like this if we use our number line drawings from GCSE. And C is the event of being between minus 1.5. So I'm going to draw another scale for Z underneath it. There's 0. So if that's 1.1, then 1.5 could be there, and minus 1.5 could be there. So C says that you have to be between here and here. Now the union of A and C says either A is happening, or C is happening, or they're both happening. Well, you can split this diagram into really 4 sections, like this. So over here, neither A or C is happening, so that's no use at all. In this section here, C is happening, but A is not. But does that count in the union? Yes, it does, because the union means C can be happening by itself, so we want to include that section. In this section in here, A and C is happening. We do also include both things happening when we consider a union, so we want this section. And in this section over here, C is not happening, but A is happening, because A was anything in this direction. And that's fine too, just A happening is absolutely fine. So we're interested in these 3 sections, which in summary are this. So really, this is just asking what is the probability that Z takes a value greater than negative 1.5. And we actually know the answer to that, because in the question before, we worked out that the probability of being below 1.5 was 0.9332. That was the probability all the way up to there. And that will be the same as the probability from here to here, the probability of being greater than negative 1.5. And so the answer is 0.9332. Now, the other way to work this out would be to do the probability of A plus the probability of B minus the probability of A and B. So we could do it like that, probability of A plus probability of B minus the probability of A and B. So we know the probability of A because we worked it out earlier. And we know the probability of B because we worked that out earlier. The only thing that we don't have is the probability of A and B happening. So now we'd have to think about when does A and B happen? And again, we need to go back to our sort of scale situations. So this says Z has to be greater than 1.1, and B says Z has to be greater than negative 1.9. So when are both of these true at the same time? Because we're looking for A and B. So that would happen only when Z is greater than 1.1. Only when Z is greater than 1.1 is this true and this is true. Well, we know the probability of Z being greater than 1.1 because that's the same as the probability of A, which is Sorry, I just realised why that's not working because I've written B when I meant to write C. So what I should have done is added the probability of A with the probability of C, which we had worked out in part 3, to be 0.8664. And then we need to subtract the probability of A and C happening, which is different. Of course, we're interested in these two, A and C. And when is Z greater than 1.1, but between 1.5, negative 1.5, and positive 1.5? Well, these two things happen when Z is greater than 1.1, but has to remain lower than 1.5, otherwise it won't meet this criteria. So probability of A and C requires me working out this, the probability that Z is between 1.1 and 1.5. Now actually that's more difficult because we'll have to do a bit of work for that. So if I draw the diagram from -3 to 3 for Z, 0, and we're going from 1.1 to 1.5. So we're really looking for quite a small number. So we have information about up to 1.5 being 0.9332. So the area all the way up to there is 0.9332. And then for 1.1, we have information about that being 0.8643. So we'd have to subtract that to find this little section, which is the probability of A and C happening. So let's work that out. 0.9332, take away 0.8643 is 0.0689. So that's what we would need to subtract here. Now if we do this calculation, so that's 0.1357 plus 0.8664, subtract that bit that I just worked out, and I get 0.9332, which is the same answer that I got before, but I think that this one's a bit more difficult, but it's up to you, depends on your perspective.